Learning target 6.6 says I can write a molecular formula using the empirical formula and molecular mass. So, remember that empirical formulas are the formulas with the simplest ratio. So remember the slide that we used for 6.3. The molecular formula reduces to the empirical formula. Now, many covalent compounds are going to have the same empirical formula. For example, glucose is C6H12O6, formaldehyde is CH2O. Notice that they both have an empirical formula of CH2O. Benzene is C6H6, cyclobutadiene C4H4. Those both have an empirical formula of CH. So how can we tell the difference? Well, we have to use the molar mass. The ratios are going to be the same, but the mass is going to be a multiple. So if you notice, remember that the empirical formula for formaldehyde is the same as its molecular formula, CH2O, that has a mass of 30 grams per mole. Glucose has a mass of about 180. That's 6 times larger. So notice that we multiplied our formula by 6. For the empirical formula for benzene and cyclobutadiene, that was CH. So its mass is right around 13. 13 times 4 is 52, which is the mass here. 13 times 6 is 78, which is our mass here. So the mass is going to be the same multiple of our subscripts. So to find the molecular formula, you need 3 things. You need the empirical formula, you need to find the mass of that empirical formula, and you need to have the mass of the molecular formula. That'll be given to you in the problem. So to find the molecular formula, we have to find out the multiple of the mass. So we take the mass of our molecular formula, divide it by the mass of our empirical formula, and that's going to give you the multiple, how much bigger it is. So let's look at some, what do we do with the multiple? We're going to use it to multiply by each subscript. So for example, for benzene, we know that the empirical formula is CH. So the mass of CH is 13.072. The mass of benzene is 78.108. So if we divide the 2, we get a multiple of 6. So we take that 6 and multiply it by the subscripts, and you get a molecular formula of C6H6. Now you can't leave it like 6 times CH. You do have to go ahead and multiply those out to make sure you put it in the proper form. So for example, if we have dichloroacetic acid, we know that its empirical formula is CHOCl. We find the mass of CHOCl, 64.468. That give us the molar mass of our molecular formula at 129. So if we divide 129 by 64.468, we get a multiple of 2. So now we have to take this 2, multiply it by all of our subscripts in our empirical formula, and we get a molecular formula of C2H2O2Cl2. Here's another problem. Compound with the following composition has a molar mass of 60.10 grams per mole. So its composition, we got percentages again. Remember, we can change percents to grams. Now the question says to find the molecular formula. The first thing we have to do is find the empirical formula, because that's the one thing that we need first. So to find the empirical formula, we're going to change our percents to grams and then our grams to moles. Remember, assume a 100-gram sample. And then we're going to use the molar masses. All right, so after you get your mole ratios, you're going to divide by the smallest, which is 3.328. Okay, so all we've done is use our empirical formula from our previous learning target, okay, 6.4. So when we divide by the smallest, we get a 1 to 4 to 1 ratio. So CH4N. So the mass of that is 30.052 grams per mole. And I got these backwards. This should be molecular formula over empirical formula. And that's going to be 2. So 60 divided by 30 gives us 2. So the molecular formula is C2H8N2.